What's going on, ladies and gentlemen, boys and girls, children of all ages? Today we have a pretty easy LeetCode problem for you, but before we get started, we're going to get right into a wildlife wild fact. Today we're talking about Asian palm civets. Asian palm civets are found all across Southeast Asia. While their population is considered to be of least concern, they are actually really big in the wildlife trade, especially in Indonesia. They are kept in cages across coffee farms where people feed them coffee beans, and after the coffee beans come out the other end, those coffee beans can be sold for much more than your average coffee bean. To learn more about Asian palm civets and Kopi Luwak, or Luwak Coffee, check out the links in the description below. Alright, so today we are going to do LeetCode question number 704 called Binary Search. This is an easy level LeetCode problem, and while it is considered a problem of its own, binary search is actually a method that you can use in many other problems all across the field of data structures and algorithms. So let's get to it. The question says, given a sorted in ascending order integer array nums of n elements and a target value, write a function to search target in nums. If target exists, then return its index. Otherwise, return -1. And before we get into an example, I'm just going to say, this is why binary search works. Specifically, the fact that the array is a sorted array in ascending order. That's the only reason we can do binary search like this. So we'll look at our first example, and we're given this nums array from -1 to 12 in ascending order. We don't have every number in that range, but that's okay because the array itself is in ascending order, and we're looking for a target number 9. If we look at the array, we can see that 9 is in fact in the array, and we are going to return its index, which is 4. If we look at example 2, we have the same array, but this time the target number is 2, and 2 is not in the array at all, so we return -1 as our answer. -1 is pretty common as a return value when we are asking for the index of something and that something does not exist. We can assume that all elements in the array are unique. That's helpful. And we can assume that the number of elements in the array will be between 1 and 1,000 inclusive. So that tells us we don't have to account for an empty array. And finally, the value of each element in nums will be within -9,999 and +9,999 inclusive as well. So we're not dealing with absolutely massive numbers here either. Let's begin. I'm going to start off with a pointer at each end of the array. So this is going to use the 2-pointer method. I'm going to call the first one start, and that's going to start off at index 0, and the second pointer will be called end, and that will start off at nums.length -1. The next thing I'm going to do is jump right into my while loop. So this algorithm is going to run while my start pointer is less than or equal to my end pointer. That becomes pretty important. That mostly covers if we have a 1-element array, we won't break out of it instantaneously because we allow for start to be equal to end. Now what I want to do is find the midpoint of this array. So I'm going to say let mid equal a math.floor, so this will round this number down every single time, between whatever start plus end divided by 2 is. So that's going to find us the very middle of the nums array. Next, I'm going to have some if statements here. And this if statement is going to be checked every single time we go through this while loop. The first thing I want to look for is if our target number is less than the nums array at the middle index. And if it is, because this is a sorted array, we can actually move our end pointer down all the way to where the midpoint is, because now we know our target number is going to be somewhere between our starting index and where the midpoint originally was. So I'm going to say end is equal to mid minus 1. Next, we have to account for the opposite effect. If target is greater than nums at mid, and in this case, what do you think we're going to do? Take a second, pause the video, let's see if you got it right. If target is greater than nums at mid, you got it. We are going to take our starting pointer and we are going to move it up to mid plus 1. If our target is greater than that midpoint of the array, then we know that it's going to be found somewhere between where that midpoint is and our ending index. So we can move our start index all the way up to that midpoint and start that loop over again. Finally, for the last conditional of this if statement, we're just going to throw on an else, because the only other possibility is that target is equal to nums at the midpoint. And if that's the case, we can just return mid, because it wants us to return the index of the given target value. So what happens then if we get through this whole array and we keep bringing start up and end down, and eventually they're going to overlap. They're going to go past each other and we break out of this while loop. Well, the only thing left to do is decide that we did not find the target value in the array, so we do as requested and we return -1. And that, ladies and gentlemen, should do it for binary search. We run the code and we submit the code. There you go, ladies and gentlemen, 76 milliseconds, faster than 92.58% of other JavaScript solutions. That's pretty fast in my book. Let's run through an example. So I'm going to take example number 1 from the left, and in order to do this, I'm going to put the example array down here. We are going to put our start pointer at the beginning, and we'll put our end pointer at the end at the nums.length -1 index. And right now we go into our while loop. And when we go into our while loop, we create mid, which is going to be equal to start plus end divided by 2 floored. So start is equal to 0 and end is equal to 5. So 5 plus 0 divided by 2 is 2.5. And then we floor it, which puts mid at index 2. So 0, 1, 2. I'm going to put that here. And mid is here. So nums at mid is currently 3. Okay? Well, we are looking for target 9. So is 9 less than nums at mid, which is 3? No. But is target greater than 3? Yes. So what do? We move start up to mid plus 1. Okay. Now we go through the loop again, and at the top we say mid is equal to 0, 1, 2, 3 plus 5, which is 8, divided by 2, which is 4. We don't have to floor it because it's already a rounded number. And mid becomes index 4. And we say, is target less than nums at mid? Well, is 9 less than 9? No. Is 9 greater than 9? No, it's not. The only thing left to do is say that 9 is equal to 9, and we return our middle index, which is 4. Let's do one more example. So we have our second array, and we go from the top. We go right into this while loop, and we set mid equal to index 2 because 0 plus 5 is 5 divided by 2, and floored is 2. And we say, is our target 2 less than nums at mid, which is 3? Yes, it is. So we bring end all the way down to mid minus 1, which is 1. And then we go through the loop again. Mid becomes 0 plus 1, which is 1, divided by 2, which is 0.5, and floored, which is 0. So we move mid down to index 0. And we do our checks. Is target less than nums at mid? Is 2 less than -1? No. Is 2 greater than -1? Yes, it is. So we move start up to mid plus 1. And then we go one more time. And we say mid is equal to 1 plus 1, which is 2. And we divide that by 2. So mid becomes 1. And we ask, is target less than nums at mid? No, because 2 is greater than 0. Is 2 greater than 0? Yes, it is. So we move start to mid plus 1. And now start is no longer equal to or less than end, and we break out of our loop, and since we have not yet returned the index of our target value, we return -1 instead. So there you have it, ladies and gentlemen. That is binary search. Not only is it a great LeetCode problem to practice with, but it is also a fantastic tool to use when doing any other LeetCode problem when you're dealing with sorted arrays. The method could also be called divide and conquer. It is a great thing to study. If you have any questions, please leave those in the comments below. If you liked the wildlife wild fact or have any other animals you would like to see me mention on this channel, please also leave that in the comments below. Don't forget to like and subscribe. All I'm thinking about now is cat poop coffee, which, by the way, was jokingly called by an old friend of mine a cat poop chino. Try to wrap your mind around that. Thanks for coming. I'll see you in the next one.